I foolishly decided to try another one. Let's see if I can get through this without like ridiculous bugs taking up half my time. Okay. Just getting things prepped. 6 to HS is where the action is. Whoa. 42 seconds. So I'm quite enjoying these tasks. I don't enjoy getting stuck on a bug and spending 40 minutes trying to fix it when I know this is just for fun. Nothing fun about bugs. Haskell seems to be going pretty well. Well, the language itself is going just fine. But I mean, it seems to be okay for these tasks. Often they're designed with languages like C or C++ more in mind. Let's see. Oh, universal orbit. You landed at the universal orbit map facility on Mercury. Orbit maps are good for finding new routes. Download a map of the local orbits is my input. Except for the universal center of mass, every object in space is in orbit around exactly one other object. Okay. BBB is in orbit around AAA. Path that BBB takes around AAA is only partly shown. In the map data, this orbital relationship is shown as AAA orbit, BBB orbits A. Before you use your map data to plot a course, you need to make sure it wasn't corrupted during the download. To verify maps, uses orbit count checksums, the total number of direct orbits and indirect orbits. Whenever A orbits B and B orbits C, then A indirectly orbits C. This chain can be any number of objects long. Yeah, sure. Okay, so that's COM is center of mass. B orbits that, and then C orbits B, and then usually we got this, sure. Here we can count the total number of orbits as follows. Yeah, so it's 42 in that one. But it's the total number of direct and indirect orbits in my map data. Okay, let's see. So we've got 6.date that. Looks like this, and we've got that example code here. Geez, the fun should come out to 42. Okay, well, let's import my gid file, main.io, empty, main equals 2. And the first thing I'm going to do is read the contents of that file. And I totally forgot how to read file contents. This is the kind of thing I need to be memorizing. But I haven't. There we go, read file. It doesn't require anything special. Okay. Okay, file contents is 5.demo for now. Stick with the simple one. Okay, so every line represents an orbit. That's easy enough. So this time I do need to split it up into lines. So let orbits equals lines contents. Okay, so So I guess I'm building a graph of these orbits so that I can do a count on them. So every everything orbits exactly one other thing, but that means there can be as many children as you want in each one. OG. So an orbit graph is either this needs to be a data, it's either a node that has, so we're just going to use strings for the planets. Are they planets or are they just things? Just orbits. Okay. Object. Okay, so I just like to, so a node is an object with a list of other orbit graphs inside it, and ultimately we've got just an object. Standard way to define a graph. I guess what do we call these? Rows trees, because it can have as many leaves as it wants in the list there. So as I read these in, the first one I'm going to read in, every time I read one in I get a new object, or maybe get a new object. Now it might be easier to do it a different way. Well, let's see. So I read a line, not that one, 6 please. So I read a line and it's got a thing on the left and then something that's orbiting it. So that would look like in the graph a com with a B in the list. So really, actually, I think what I want here is a map, because I want to map com to B, and then if later on something else is orbiting com, I want com to map to the list of B. Yeah, I think that's going to be easier. So for example, each orbit here, I can split them into the center and the orbiter by doing words when equals. So this is my little gid thing that splits something, string, up into a list of strings where using a character to split them on. So I want to split on the orbit symbol, and then that will hopefully, hopefully there's nothing left after we get the center and the orbiter out. So for each line we can get the center and the orbiter. And what do we do with that? We would add it into a map, I think. So how am I going to calculate the number in here? Total number of orbits is T directly orbits C. Yes, it does. And indirectly orbits B and com. Yes, it does. So that's 3. L directly orbits K and indirectly, which is 7, com orbits nothing. You do that. So you end up adding up the distance to each path in the graph, each node in the graph. So com is 0, and B is 1, and C is 2, and G is 2, and H is 3, and you just end up adding all those up. So if I've got a map where com maps to B, for example, B maps to C, for example, C maps to D, for example, and then D maps to E and I, for example. can I do that calculation? So I start at com and I give the thing it maps to the value 1, and then I repeat the process and I look for that thing and I give the things he maps to a value 2, and then I repeat and then I repeat and then I repeat. Yes, I think that's what I want. So I think what I actually want is a map, and I want to build up a map as I go along. So the map is going to be from object to object, no, object to list of object. How am I going to build that up? So every time I see a line, I am going to put into the map. This is where I need my Haskell. Okay, and I'm going to put into the map that thing, unless it doesn't exist there. Jeez, what's going on Haskell? Is it not data.map? Yeah, this is a map on, I don't want this. That map is what I want. Data.map. Data.map.internal, that's not what I want. Data.set. Data.text. Or I want a data.map. Yeah. Don't represent large virtual data. Well, I don't know. Should we do data.map.strict? I don't know, maybe we will. No, I'll just stick with this. I hate efficiency. So, we don't insert with anymore. Use data.map.strict insert with. Okay. Alright, I better use data.map.strict, I guess. I don't know why, but that's okay. So when we insert with, combine the new value with an R, no, we don't insert with. Insert a new value if the key is already present. Associated value is replaced. Insert is equivalent to insert with const. Insert with a function, combining a new value and an old value. Oh, that's the one we actually want. Yeah, we do want to insert with. Okay. So I have to do a map over, but let's think about what I want to do at each line. I'll just write a little function called process line. It's a string and it gives me back a, I don't know, it doesn't give me back an anything because it has to adjust the map somehow. But if it gets in a string, we want let center orbiter blah 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 to be the words when on the string. Then we want, so that's in the map that has that thing pointing to that thing. So building maps is tricky. Building a map like this is tricky. Ooh. Well, I guess I want to pass in a map to start with. Call it M because this map word is massively overused. You're a map.map. So if I pass in the map that I'm working on and the string, then processing the line means grabbing those things out and inserting into the map the new thing. And I do want to insert with. So insert with requires a function, a key, a val, and a map, and it gives me back another map. So this is a map from object to list of object. Okay. Insert with. So this function here tells us how to combine values when it finds another one in there. So we're definitely inserting a key with center and orbiter. But if you already, no, with a list, because this goes to a list of, remember? So it's going to singleton list of orbiter into M. But if you already find a value in there, OL, so an orbiter list, and I give you another one, OL prime, then I'd like you to put them together. In fact, I can just use plus plus directly here to say concatenate, insert with concatenate, do the job, and that gives me back a new map. So now I just want to fold this over the, that needs to give me back a map, fold that over all of the lines. So final map equals fold, and I always get my folds mixed up. Google fold L. Never know which direction I want to fold. Fold R is more efficient, fold L is less efficient or something. Function goes first, then the initial value, then the list. So I fold L process line with an empty map. I think I can just put map.empty in there. And I want to put that over the orbits. Okay, let's just see what that does. No, that's just loading up 5. 6.hs is going to give me an error. Perhaps this statement should be in a do block. It is in a do block. We've got this damn space problem again. So, pause error, perhaps this statement should be within a do block. Sure looks like it's in a do block to me. What have I typed wrong? That's all the same. Type object equals string, that's fine. Import qualified as, that's fine. Oh, it's down here. Oh, that's it. It's got the arrow left over from that. That's an equals. And I'm trying to just tell it it's a map, but it's not really just a map. I'm gonna OMap for orbital map is a map.map. I just don't want to type this over again. Object to list of objects. So it could be an object map or an orbital map, who cares? Take in an OMap, give me back an OMap. We're good to go. So that's just object, not objects. Programming in. Okay, so we don't like, should be map.insert with, because we have to insert everything qualified with maps because they have so many things that overlap with lists. And main. Okay, non-exhaustive patterns in orbiter nothing. Center orbiter nothing. So when we did a words when it didn't match with this for us. So let's just double check the 6 data. Oh, there's a line there that's empty. That won't help things. Still no good. Do I have the right file that I'm working on? That's demo. Did I leave it? No, 6.demo. No, there's no blank line there. What are we doing wrong? So this is tricky, right? I've done a pattern match here on something that may or may not. Doesn't necessarily pattern match. Words when gives back a list, but if the list has got no elements or something, then we're not going to get what we want. So I just want to see what words when is returning for everything. So let's do that instead. Let's just map words when equals over orbits and put string line that. And I'm using the wrong kinds of comments because, you know, too many languages in my head. Did I not save? I did not save. Okay, so I can't map words when over orbits. Couldn't match string with char. So orbits is a list of strings. Yeah. And words when wants a string, right? Ah, dollar that, I don't think. No, dollar should be fine. Oh, no, it's the show thing. Always forgetting, oops, always forgetting the shows. Okay. All right, so it's pulled out something weird. Oh, because it still says 5.demo, not 6. That's better. Okay. So we're getting what we expected there. Let's try this again. Okay, so final map, fold process, last thing. Oh, we'll get this last thing and do block problem. Okay, so now, so B's mapping to G and C, C's mapping to D, com's mapping to B, D's mapping to I, so on and so forth. So if I can now do the distance of every node. So distance to a particular string in a no map is an int. So distance to S in map, why are you red? Distance to any map is if I look up the map for com and find a thing. Well, first of all, if I look up, if the string is com, then it's 0. Distance to S map is, I then look up, no, oh, hang on, that's where I'm getting a bit confused now. So the distance to com is 0. The distance to B, I have to look up com and then I'll find a B, so I get 1. So I always look up com and then I get something back and I look that up. I have to have the starting from here as well. Okay, so that's where I'm starting from. If starter equals S, then I'm at 0. Otherwise, I look up the map. So I need to look up. It's just a lookup. I give the key and I get back a maybe. So I'll do case lookup. So I look up the starter and I get back a value. And when I get back the next one, I just keep looking for mine with the new starter. And what did I get back? I had 1, 2. That's a just, not a maybe. And if I get back nothing, then there's a problem. I'll just get back 0. And that's all. Okay. So if I ask for the distance to com, should get 0. But I've got to tell it where to start from. So we always start from com, I'm guessing. Ugh, my fingers are all over the place today. Distance 2. Just none? No? I'm forgetting the names of the maybe constructors. Oh, couldn't match type with maybe AO. So nothing to 0. So we definitely want to give back an int. An expression case lookup. Couldn't match expected type. A list of strings and something to a maybe BO with actual type. What the? Oof. Not doing anything strange with my syntax. Just going to check that nothing is the right one. Where did my maybe go? Nothing and just, yes. So if I look up starter, just check I got that right. Lookup takes a, oh, I haven't given it the map. Lookup starter in map. Couldn't match with string string. So who's passing you string string? This one is, because I haven't done the distance to, given it the last parameter, but that's not working either. Oh, map, it's got me again. The map is a word that means something, and it's a keyword. So I'm still using it somewhere. There we go. No, couldn't match with string string. Go back to this again. So your distance to takes a string and an OMAP. String, string, OMAP, string. Oh, there's something going on with this. Let's kill this and see what the syntax highlighting does. Okay, so it's giving me a different error. Evaluate in the third argument distance to, namely final map. So distance to, it doesn't know what distance to wants this time. So object is a string. Next is not a single element. Next is a list. So when I hit the distance to next, there are multiple possible answers. There might be many of these, me and I and rah, rah, rah. And I have to look for the one I want. Okay, I probably got, feels like I've got the wrong object, like the wrong data structure here. And that's why I'm having to do this in such a complicated way. So I don't know if I'm going to find it in the first one or the second one. I'll get back a 0 if it's not in that one. +1, +1, +1. So that will be the smallest. So what I actually want to do is map /n to distance to n over all the nexts. And that'll give me something back. And from that list, I think I want the maximum, because 0 is what I will get out plus is applied to too few arguments. So this distance to NSM is the function. Take in the n and then apply that over the next. So that's, hang on. No, that's an int. So that's a list of ints. And then the max of a list of ints is an int plus a 1. Couldn't match fit that int with a list of int to a list of int. I probably got the wrong thing for max. Yeah, okay, max takes 2 elements. I want a max on list. Can I get that? For a list of A to an A, I'm going to do it. There we go. Not map.lookup. There's a lookup available on lists as well. That tries me banana. 0. Good. Okay, so it thinks com is 0. What's another one I think is going to be there? If I start at com and I go looking for B, I want you to find it in 1, please. 1. Now, if I start at com and go looking for C is 3, 4, 5, so E should be 5. E should be 5. Oop, E came out to be 4. Is that what I want? 1, 2, 3, 4, yes. Now let's pick one where there's multiple paths. Well, I and E both want to come out as 4, so we've got that one. Let's try I. 7. That's not good. So we grabbed the maximum, and that's because this all added up to more. So when looking and couldn't find it, this I don't like. So the other choice is to make it a maybe int in case you can't find it starting from there. I've definitely got the wrong data structure here. This is way too much. So then we say you can't find anything, but now this guy is a list of maybes. So we can't just map max. Whoa, definitely got the wrong data structure here. So I'm not getting back a list of integers in this one here now. I'm getting back a list of maybe integers. And yeah, this is where a bit more practice on these might help because they have the right data structure instead of the wrong one. My list of maybe integers. Well, can I get the maximum of a list of maybe integers? No. Well, let's just... I know there's an easier way to do this. There's definitely an easy way to do this. Well, let's just ask Google. Just filter out all the nothings. You can do that, right? Cat maybes. List of maybes and returns a list of just, yeah, perfect. Data.maybe. So I just got to cat all the maybes in that one, then get the maximum, then put it in adjust. Come on, it can't be true. Don't need that anymore. That's definitely not the nicest way to do it. No instance from num maybe int. Yes, I know that. Let's do a bit of indenting here to get this to work. So you're definitely over there. Your cat maybe. Oh, you worked. Maximum on an empty list. That's okay. We can handle that. So that is, now we do a case on here. Definitely not the right way to do this. So not the right way to do this. Of empty list goes to nothing. Anything else goes to maximum x's plus 1. Oh man. I just want to get this done and move on. No! Okay. Not just. It's one of those times where if I could use the maybes and everything would just like work out for me. There we go. I got what I wanted. But I'm still not got the answer yet because I've done this the wrong way for sure. And what I'm going to do now is going to find all the different possible things that might be in there. Just collect them up. And then I've got to do each one, get their distance, and add them up. So, all orbits in a OMAP is a list of objects. I need to map over all of the what happens when you do these. You get stuck in a way of doing it. Just like, if I've just got to get it done, so I'm going to push on. You don't stop and think about a smart way to do it. Which means I don't like, well, I like doing these, but I don't think it's a good thing to stream because you get to see me watching doing the wrong thing. That's strict. So what I'm looking for here is a way to get, to loop over it, to get all of the different things within it. I just want all the values actually. So map with key, blah, blah, blah. Traverse with key. Fold, here we go. Fold the values on the map, given the right associative binary operator. Fold the left on the map, given the right associative binary operator. That's what I want. So all orbits equals, everything on the right is a list. So I want to fold L, and I want to fold with a plus plus, starting from an empty list, cross OM. This is a classic example of something a Haskell programmer should never write, because I can just take these two parameters off, and then this means the same as this. But I just like to do it. Targets equals all orbits, OM, and then so I've just given names to a bunch of things that didn't need names, where I could have done it faster. And again, I put S on there, and you're OM, but you are final map. Okay, so GCB, that looks like all of the different things that I might have. And they should all exist just once, I suppose, but let's make them unique anyway, because I can't think that hard. List of A to list of A. Oh, this Hoogle thing's cool, by the way. I just put in something that I think has the same signature as what I'm looking for, and this time I'm looking for something that maybe makes the list unique. And that would be something that went from a list of A to a list of A, but I can't find one. So it's not just built in, so we'll just push on. Is it possible for doing that to give me things more than once? No, everything orbits just one thing, which means everything appears on the right just once, which means it's totally safe to do that. Okay. Okay, so now that I've got all the orbits and I can get the distance to, I want to let all distances equals map distance to, well, I've got a map slash orbiter to distance to orbiter final map over all the targets. So that's a list that has the distance to all the targets. And then finally, I want to fold that up with a plus. And that needs a show as well. Let's see. Do we get 42? Do we even get it to work? Final map. So distance, because with distance 2 I have to give it the start and the one I'm looking for. We always start from com. So these are all maybe integers. So I've got to strip all the maybe, well, no, I don't really have to strip all the maybe integers, do I? No, I don't. I do. Yeah, I do. Let's just do it as the, we shouldn't have any justs over there. But I shouldn't have any nothings. We were just using that along the way. 42, hooray. So the list is just two. There's a silly, I only needed the maybe int in the middle of the distance to indicate that I was failing. So this, I definitely don't like this at all. And I'm willing to bet that when I run on my code, there'll be a problem. Hello, Cryptsock. And off it goes, too much output. So it thinks 25,447. Now is that the thing I'm just putting into my answer? Or is the total number of direct and indirect orbits in your map? Let's see. All right, it worked. Woo. So this, I'm going to stop here because last time I pushed on and then found the bug and everything. I think it's more useful to give you a concise and working thing, and then I'll do the rest of my own for fun. So all these maybes here, I think that's an indication that I haven't structured it right. I shouldn't have to case match over and over again. So that's another reason not to push on to the next half. On my way home, I will ponder and see if I can't come up with a better structure for this. Or maybe I can just push on like this. But that's not too bad, actually. So most of this is junk where I'm just collecting. So this doesn't need to be here in Haskell land. So I can just map fold, but this, I like this, Control C, can go directly in there, right? But I find this so hard to read. Let's see if that still works though. Yeah, so that doesn't need to be there in the Haskell version. And then like none of these need to be here. And half of these don't need to be here, right? Final map, I could put that directly in over there. Targets, I could put that directly in over there. But this is probably a reasonable Haskellish version of the first one. Not too long. And most of the garbage here is in this thing I shouldn't be doing. All these justs on the ints. Okay, well that'll do for now.